Hey guys, today we'll be talking about disc clutches. Probably one of the biggest concepts in any vehicle. You often notice that behind the tire, there's like some weird looking round metal part component that the tire fits in, and that actually has a lot to do with the whole concept of the car and how the braking system pretty much works. So let's pretty much get into that. So as you can see on the top left right here, this is basically what you see behind the tire. These clutch brakes are considered to obviously cause friction. So your car can eventually stop because friction is what causes it to stop. When two things slide together, the traction of the wheel and the things basically sliding into each other will cause eventual friction and make the car stop. Um, there are actually three type of main requirements to be met in order for it to be considered a proper clutch. The required friction torque must be produced by an acceptable accuting force, which means that the opposite force, sorry, the force that's applied has to be greater than the one that's being drawn onto you. So, example, if you're going really, really fast, your clutch should be able to stop the car according to the speed it's going. It shouldn't just brake or shouldn't just because a lot of older cars you notice because of the rusting that happens in clutch discs and stuff, they'll just eventually give up. The brakes will stop working, and that's how you get a bad car basically, or the brakes aren't working. So you may have to make sure that the friction provided by clutches is efficient, is significant enough for the opposing force. Number two, the energy converted to the friction heat must be dissipated without producing, like really, really hot temperature. So basically, it shouldn't rub together so much. It has to have like basically a silver lining in which that it stops the car but doesn't produce overheating, because as you know that excessive friction could cause the high temperatures would eventually cause inflammatory problems in the car. Something could just literally just burn off, or just eventually, if you rub something really, really hard together, it could cause some sort of spark. Obviously, in the car's case, that probably won't happen, but it could probably burn it off, if anything. So that is one big concept. And third, the wear characteristics of the friction surfaces must be such that they give acceptable life. Yeah, it's exactly what it is. So it has to give a significant life. So a car which is good at doing such things, like a Civic, for example, would have significant life into it, so that it will give you, that required friction for a suitable amount. So over, say, 10 years, over 20 years. 20 maybe is pushing it, but like, over maybe around 15 years, you'll actually eventually have to change or replace your disc clutches. All right, so this is basically a disc clutch diagram. I have two right here. I got one here and one here. This is more colorful one. You can see all the components and parts of it. Uh, Basically, the figure shows the automotive type clutch used with standard 10-minute transmission. So everything pretty much basic you find in like an old Civic 2000, 2001. A series of circumferentially distributed springs and slotted coin disc diaphragm spring force of the pressure plate towards the flywheel, clamping the clutch plate between them. So basically, you have something that kind of presses. It presses the disc clutch, so it stops. Like, the pads kind of like force into the wheel, so it kind of stops the wheel from spinning a lot faster. The hub of the clutch plate is the spline connected to transmission to input shaft. Yeah, you can basically see that right there. And then there's a lot more. Like the clutch has two driving surfaces, flywheel and pressure plate, and the two driven surfaces, the two slides of the clutch plate. Yeah, you can see that right there as well, right here in the clutch plate. It kind of drives in together to the drive shaft. Moving on. So basically, this is the construction of a display. Uh, Figure illustrates the principle of the multi-dust clutches. So there's obviously layers to it. It's not all one thing together. It gets a lot technical. That's why you have a lot of more equations and see that you have to use. You'll see that further on. Most multiple dust clutches include the ones used in automotive automatic transmission operated wet. So there has to be some sort of lubrication for it to properly, work. If that's the proper terminology to be used. Um, so yeah, moving on. There are a bunch of equations that are required to be solving these kind of equation problems with disc clutches. Obviously, it is a big concept in the whole machine elements. Not only that is disc clutches used in in the automotive industry is a lot used in a lot more machinery, such as let me just think on the top of my head. Not fully in conveyors, but conveyors have a similar thing where there has to be significant friction for the belt to stop. I worked at Canada, Canada Post basically as equipment engineer. So there has to be significant friction. That there's something that kind of clamps onto the it's like a very slippery type of material for the conveyor belt, right? And then that has to stop so it allows nothing else to move onto the belt and everything just sticks in place. And these belts are like in an incline too, so you can't have it. Everything has to be calculated in a way that it holds sufficient weight of parcels and packages. So here's this basic equation. You can see right here, F equals pi p bracket r squared, and then you have I'll just explain what pretty much everything means here. So F equals total normal force acting on the area of contact. P equals uniform level of interference pressure. Capital T equals total force torque that can be developed over the entire surface. R is the radius of the friction surface. O stands for outer, I stands for inner. So you see O right here, I right there and O right there. And then N is the number of friction interferences as an even number. It has to be an even number. And F, you can say the fancy F, is the friction coefficient. That is something basic you find since like grade 11 physics. Okay, and then we have the uniform rate of where interference happens. So this assumption is valid for a worn clutch. This is this equation explaining what happens when there's worn clutch. A new clutch would have greatest potential wear at the outer radius after the initial break-in wear. The friction lining tends to wear at the uniform rate. This uniform is where assumed result from an uniform rate of friction work. So obviously you see, and then there's also a P max component to this. It's the greatest pressure which occurs at the inner radius. And there's a lot more. And then there's also a bunch of friction coefficient or dynamic friction coefficient for different type of materials. For example, for molded, it's 0.25 to 0.45, or for cork, it's 0.30 to 4.5, 0.5. So there's several type of coefficients depending on what kind of surface you're interacting with. That's pretty much it. So I know this is a really quick rundown of this clutch. You can go on and on about this, but it's a simple breakdown that I gave you guys. And yeah, hopefully you guys enjoyed. Thanks so much.